Hello?
Hello?
Hello. Good afternoon. Okay. Daniel, Sandra, can you hear me?
Yes, I can hear you.
Okay, very good. So, hello everyone. We will wait 1 or 2 minutes. Still, there are some people joining the meeting. Let's try to be a little polite with them. And then we will start. Okay, still going on. Okay. Thank you for waiting. Okay, getting more people. All right. So let's start.
All right.
So, hello everyone, and welcome to today's session. This is Alberto Guerri, VP of Sales at Sensofar Metrology. I hope all of you feel good and healthy. Today, we will introduce a new optical microscope, which has been designed by Sensofar to cover wider areas. I would like to introduce today's presenters, Sandra De Pedro and Daniel Secchini, both application specialists at Sensofar, with an extensive knowledge about our products and applications. We split the webinar in 2 parts. Daniel will go through a presentation of the solution and main capabilities of the Swide, and Sandra will run a live demonstration. At the end, we'll have 10 minutes for questions. I will try to reply. A recorded version of this webinar will be available. And before Daniel starts, I would like to make a couple of questions to know a little more about the audience, about you. So let me launch the poll. Here is coming the first question. Now, so we'd like to know which market are you working. So our apologies because we can only have 5 answers. I know there are much more than that, but it is what it is. So gonna change that. Okay. Okay. Let's have a minute to reply, everyone. Still someone has some doubts about that. Okay, 80% already. All right, so I close it. Okay, so what is still replying? 60 seconds making now. I close it. Here you have the results, Daniel. So it's very diverse. Okay, we have a little bit of everything. So 18, 18, 30, 24, and 76. This is not 100. That's funny. All right. So let me go with the second questions for you. What non-contact optical inspection system do you currently use? Is it standard stereo microscope? Is a digital microscope? Is a profilometer, like focus variation confocal or interferometer? Or is it a fringe projection, like the one that we are presenting today? I think you can reply a few of them.
Yeah, it's got to be.
Yeah, because it's not one. That's the reason.
Yeah.
Okay. Close to 80% people. All right, so close it. Show you the results. Well, again, we have, okay, that sounds interesting. We have a lack of fringe projection in the market. So let's see if we can explain a little bit what a fringe projection system is doing, and if it's interesting for you. So that's all from my side. Now I switch to Daniel. So please.
Okay. Excuse me. All right, thanks, Alberto. Like Alberto said, my name is Daniel Sakakini. I am a application engineer in the North American territory. My background's in mechanical engineering, and just wanted to reiterate again that we're really thankful that you guys are with us right now. Glad you could take some time out through this difficult time. So just a little bit about the format of the presentation. I'm going to kind of run through a bit about Sensofar, a bit about our current portfolio, and then talk more in depth about the Swide, some applications that we think it'll fit into really well, and then go over the software package that will come with the device. So a little bit about Sensofar. Here is all of us in a picture. We were founded in 2001 in Terrassa, about 20 minutes north of Barcelona in Spain, and we are 100% a private company. So everyone that has a stake in the company works under that roof. And we design solely optical instrumentation packages for micro and nanoscale surfaces. We're a global operation. We've got about 1,000 systems installed all over the world in a number of the applications that a lot of you are involved in. Our base in the US is in Newington, Connecticut, but we've got a network of distributors all over North America. If you're ever in town, please let us know, and we'd love to host you for a day. All right, so I'll jump into a little bit about our current portfolio. A lot of you might be familiar with what we've got. So on the far left there is the Swide. That's our new system that we're talking about today. We've also got the S-Neox in the latest iteration, which includes interferometry, confocal, and focus variation all into one system. First one to come to the market with that. That system also has a 5-axis module that can be installed along with the system, and that's in the middle there. And that's great for, we've seen a lot of use in the tooling industry, anywhere that has sort of a cylindrical profile that needs the full 3D surface characterized. We've also got the S-Lynx, which is our manual XY stage device, and then finally the S-Onyx, which is kind of an inline solution that features just interferometry. All right, and then all of these solutions are available as integrable heads that can be taken off their base and used inline, excuse me, for QA, QC checks or any other use that you might have. And once again, it's the S-Wide, the S-Neox, the S-Mart, and the S-Onyx, which is only interferometry. So that's kind of our current portfolio. And we were pretty confident working in the angstrom and nanometer range, but a lot of customers wanted a solution that was sort of able to take to acquire an image of a wider area more quickly in the millimeter and even sometimes centimeter range. So that's where the S-Wide slots in. And yeah, looking forward to talking to you a little bit more about where we think it will fit specifically and what the system looks like. So here's the basic setup here in our standard configuration. You've probably seen this stable arch design before in our other products if you're familiar with it. A motorized XY stage and a pretty compact, robust solution. So just before we dive a little bit more in depth, just a couple of key topics. The beauty of the S-Wide is that it makes a lot of your routine ops a lot faster with just a one-click Z-scan that doesn't require a motorized Z-stage. So you can take a height measurement up to 40 millimeters. Excuse me. We're also able to achieve sub-micron repeatability in height over the entire extended area. And create some really nice true color images with a 5-megapixel camera, and can also do 3D CAD model comparison very easily inline or wherever else you'd like to do it in your process. Okay, so just a couple of the hardware nuts and bolts. The system weighs 55 kilograms or 121 pounds if you live in the States like me. And as a standalone integrable head, it's only 18 pounds. So a pretty, middle of the range light solution. And then it comes in our usual configurations, the standard, which has an XY stage of 150 by 150 millimeters. We can extend that for higher samples with a high attachment. And then we've also got our wide stage, which extends that to 300 by 300 millimeters and can also accommodate higher samples with the high and wide. Excuse me, like I mentioned earlier, we don't have a motorized Z stage because it's just really not necessary. And we've got an adjustable column and lock position that can accommodate samples of 105 millimeters for the standard config and then 280 for the higher configuration. Okay, so the fringe projection setup that we're running has both a green and a blue LED. And the advantage there is that for pieces that are a little bit more reflective or vary in some way, you have the option to switch between two wavelengths of light that might help image your sample better. So that's pretty unique in the market and really excited to have that in there. And then we've also got a ring light, which produces the illumination for the true color images, a number of which we've got as images later on in this presentation. All right, so a little bit about the internal design. You can see the two projectors there that are projecting onto the sample, the fringe pattern. And that is, right in the middle is the bi-telecentric lens and detector. A couple of specs here. Our working distance is about 80 millimeters. The field of view for one image is around 35 by 29 millimeters. And the spatial sampling is 14 microns. We're able to achieve up to 300 by 300 millimeters through stitching. And this setup, like I've mentioned a couple times earlier, allows us to get a true color image and a fringe projection height map with every single acquisition. So really some awesome advances with this product, and the speed and versatility that it has is pretty exciting. So get into a little bit more about that. Just a couple more dimensions. The thing's about 2 feet wide by 21 inches deep and about 20 inches tall. So a pretty run-of-the-mill kind of standard package and size for this. Doesn't take up a lot of space. So that's pretty much all I want to talk about on the hardware side of things. I'll talk about some more specs a little bit later, but for now, let's jump into some applications where we think the S-Wide slots in really well. So some of you in the poll, it looks like some of you are involved in these industries here. We work with our current portfolio, and all of these industries have a lot of experience interfacing with people in the watch industry, medical devices, archaeology, and consumer electronics, etc. So just a couple examples from those fields. Excuse me. So the first is an example of a molded tablet. And if you look on the bottom right, you'll notice that this image was taken in only 5 minutes. So this is a height map that's perfectly acceptable for any tolerance checks, measuring coplanarity or flatness. And it was created through stitching a 190 millimeter by 120 millimeter area through stitching. So again, just a significant advance and time saving in measuring this part. And then we've got another consumer electronics example. This is a hard disk, and here you've got another height map that was taken in only 3 minutes. And you can even see some scratches on the surface of the disk there, which again, just gives you any critical dimensions that you need in only 3 minutes. Okay, another cool sample is this pinned chip here. And I think what's important to see with this example is that this is a true color image, but also it's a true height map that doesn't really suffer from any shading problems. So because we're using a bi-telecentric lens and the two projectors, the setup allows us to have no parallax errors. And then we're able to easily take that linear profile that you can see down there and measure the trough in between each of the pins. And this was imaged in only 2.5 minutes and is a stitched area of 87 by 73 millimeters. All right, an example from additive manufacturing. I'm not sure if any of you said that's something you work in, but this is a gear, a small gear that fits in our one-shot acquisition. And it's made out of a pretty difficult material to image, but the Swide handled it no problem in only 11 seconds. So important to note there that we could actually, if you didn't need the resolution that you see in this height map, we could actually increase the speed of acquisition to 3 seconds by dropping the resolution of the detector. So again, I mean, that's incredibly fast on a part that's usually pretty difficult to image. And then we've also got a progressive addition lens mold here. And this has undergone a form removal to take out any overarching shape, and then can once again be measured for coplanarity or flatness. This was a stitched piece that was acquired in 1 minute and 44 seconds. All right. And then another lens here. This is an illumination lens. So not an optical lens, but producing light. And you can see that it's got all the usual kind of critical dimensions that it needs. It's got an angle measurement, a radii measurement, and a linear profile measurement down there on the small screenshot of SensoView. And in 11 seconds, easily able to characterize kind of the full sinusoidal shape on top of this lens. And yeah, okay, that's it on that one. And then an example from another industry, from the watch industry. This is kind of it shows how awesome this true color camera image is. And you can see some scratches here on the back of this watch. Once again, taken in only 11 seconds and just acquired through one shot. No Z-scan required, and also didn't require any stitching. So that's the advantage of having a wide area with every acquisition. So pretty awesome. Okay. Finally, another example from the watch industry. Here's a watch ring that we've taken a ring profile of so that you can kind of see that the watch has a bit of a warp in that ring and might be something on a QA or QC check that allows for pass-fail analysis. And again, imaged in only 1 minute. And then we've got a side-by-side comparison of a true color image of a dental implant compared with the height map. And I think we see a lot of potential in this area. This is another example of a stitched image that took only 4 minutes to stitch together. And I think there's, we see a lot of, for rough surfaces like this, the Swide really shines in its ability to acquire, every critical dimension needed really, really quickly. Just a couple more examples. We've got a razor cover kind of to protect the internal blades. And you can see that each one of these blades on the cover can be characterized. And again, this shot was taken in only 11 seconds. So just want to reiterate, it's super, super fast. And then finally, a shot of the maximum area through stitching, which is 150 by 150 millimeters. Like I said earlier, we can expand that to 300 by 300 millimeters if your application requires a bit more XY stage area. This is a laser etched surface, and just wanted to reiterate how fast it can be done. Took only 3.5 minutes to characterize this entire surface. All right, so at the end of the day, this is a metrology tool. And I'm sure a lot of you are interested in the accuracy and repeatability of the device. So the step height accuracy is 2.5 microns with an uncertainty of 50 nanometers. So once again, represents a significant advance in the market. So we're really excited to have that capability. Also can measure area and profile roughness with an accuracy of 1 micron and 10 nanometer uncertainty. And then in the background, we've got another PCB that was imaged in 38 seconds through stitching and a little bit lower res. So pretty awesome capabilities of the SWide. And I think no other picture kind of illustrates it better than this one right here, another PCB board that was taken through a couple stitches. It took about 5 minutes to acquire this picture, and you can see we've taken some profiles in the background there. This piece has some very large Z deltas, and we're confident in saying that you can shoot up to 40 millimeters in one acquisition. But just interesting to note here that we're able to characterize a feature on the far left edge of this PCB board that has a step height change of 67 millimeters. So, and then a little bit more about the capabilities of the telecentric lenses. Like I mentioned earlier, because we've got the two projectors and the bi-telecentric lenses, we don't suffer from any parallax errors. The lenses also mean that we don't have any difference in magnification depending on what depth in the field of view you're at. So the magnification is consistent throughout the whole depth of field. And then the advantage over monotelecentric lenses is that the point spread of the projection is a lot better with the bi-telecentric lenses. So I'm sure you've got a lot of questions about that. I'm just going to talk briefly about the software and a couple of accessories that are available, and then I'll turn it over to Sandra to do the live demonstration. All right, so a little bit about the software. I'm sure a lot of you, if you've worked with us before, are familiar with SensoScan. SensoScan is our acquisition software. It's actually pared down a little bit for the S-Wide because calibrating the S-Wide takes less than 5 minutes. So very fast, doesn't require as much usage of standards to calibrate. And so although it has many of the features that the S-Neox SensoScan has, it's faster to calibrate, and you'll see a little bit more of it in the live demo that Sandra does in a couple minutes. And just like regular SensoScan, we've got the ability to plug in recipes from a text file that you've got. So you can plug in your coordinates of any areas of interest and kind of generate a recipe for what areas you'd like to characterize. And then you can string those together through stitching using our extended measurement module on the right there. So it just allows you to characterize a larger surface through the usage of XY scanning. And here's an example of SensoView. So we have we split our software in two. We've got the acquisition side, which is SensoScan, and then the analysis and viewing side, which is SensoView. And you can see there, we've got a little standard that we use to measure kind of all critical dimensions, radii, angles, and such. And then in the background there, you can see a profile taken that shows all those measurements there. So that's SensoView. All right. And then if for extended analysis, to look at roughness and surface area roughness, we've got Senso Pro, which also very, very helpful for QA, QC checks, can lead to the ability to pass-fail items. And just like to draw your attention to the surface roughness characterization analysis right there, that little image that says results summary. It's you can kind of see the roughness jumps from 7 to 11 microns, and the S-Wide's able to capture that entire the entire variation of that range without any adjustment in the software. So just once again to show how easy it is for this device to capture a wide image and a lot of change. And then finally, if you'd like to do more in-depth CAD compare, we're pretty excited about a partnership we've got with Geomagic, which is the software that we use to perform CAD compares. Just a couple of pictures of that. You've got the CAD image in the background and the height map in the foreground. And then here's another part that shows our ability to check for tolerance and form deviation. All right, and finally, just give a brief summary of our accessories package. So we've got two options, well, two items, not options, excuse me. We've got a step height calibration specimen that comes with the system that both of these are verified by Sensofar. Step height calibration specimen, and then we've also got a critical dimensions piece, which I showed a little bit earlier, which just has a little bit more features to just calibrate the system with. I think for now, guys, that is pretty much it, and I'm sure you have a lot of questions. Thanks for your time. I'd love to hear your feedback, what you think about the system, and yep, hope you're all staying healthy. And I'm going to turn it over to Sandra at this point to do the live demo of acquiring a couple images. So thanks.
Thank you, Daniel. All right, Sandra.
Yes.
Now.
Okay, you see my screen? Perfect. Okay, so now it's the turn of the live demo. We are going to play with 4 examples to see how the system works. In the screen that I'm sharing with all of you, you can see the acquisition software that my colleague Daniel commented in his presentation. The name of this software is SensoScan Swide. So let's start with the first example, which corresponds to one of the specimens that we have. I show you in the camera. And now we placed on the flat plate. Okay. So the region of interest corresponds to one field of view, which is the area that we can see here. Just by clicking Auto Light in this icon here in the up part of the software, and then if we move to the bottom part on the right, we can click the Acquire, and the topography will be generated. Automatically, the analysis software will be opened. Here we have the topography. This is how it looks like. Okay, we have here the 3D view. And here on the top left part, we have some important information about the topography. For example, we have general information as the area or the dates, the time. A little bit below, we have the scanning details, as for example, the use technology, the number of measured points in 10%, and the acquisition time. Another thing that I would like to comment on is the 2 viewing options that we have. Here we have the 3D view, as you can see, and just by clicking here, we can change to the 2D view. We also have different rendering options that we can see here. For example, if we start from the left, we have the height map, followed by the standard stack image with a combination of the height map and the stack, and then the color information. So if we want to obtain a profile, we can move to this upper part of this column that we have different options for the profiles. In this case, we are going to choose the vertical profile by clicking this icon. here in the topography, we can expand it. And in the lower part, we can see the corresponding representation of the profile. On the right part, we have different options to choose to measure dimensions, such as, for example, the circle. We can adjust it here. Then we can choose the distance between this section, or maybe we have some interest in this part. So now we can move to the next example. I'll show you first in the camera. This is a structure made of Teflon. And due to this material, for an optical profiler, it's difficult to measure. So let's see how it works with our system. We can place it here on the flat plate. And if it's not in the desired position, just by pick and drag, we can move the sample where we want. We can do it vertically, and then we can do it horizontally too, and on diagonal. So to obtain the topography, we are going to use the same parameters as before, and we are going to click Acquire. And as the same as before, after the topography will generate it, the analysis software will be open. We have again the 3D view. This is the color information, and in that case, we are going to go to the height map. Here, choosing the first holding, we can remove the substrate just by moving the end of these bars. Whoops. ¿Qué ha pasado?
¿Qué es lo que pasa, Sandra? What's happening, Sandra?
I don't know. Everything was shut down. Can you see anything? Can you see anything? Can you hear me?
Yep, we can hear you and we can see it now. Can you hear us?
I can hear you, but everything was shut down.
Okay.
I don't know why.
Well, we're still able to see your screen right now, so.
You can see my screen?
Yep.
Okay. So I can continue, or?
Okay. I'm sorry, I think now we are having some issues.
Yes. Okay. I will take again the topography.
You hear us? I don't think we can hear you. At least I don't.
You can hear me? Alberto, you can hear me?
I can hear you, Sandra. I'm not sure if.
Okay. I don't know if the rest of the attendants can hear me.
Okay, you can hear, not me. Okay, I will check. That is my problem.
I think everyone can hear you, Sandra. I think you're good to go.
Apologize. I don't know what happened. Maybe the connection was wrong. Sorry.
No worries.
Continue with the first holding for removing the substrate. just by moving the end of the bar, just by moving this end of the bar. And in that occasion, we can select the circular profile. We can adjust it just by clicking these marks on the circle. We can adjust. We can move it if we want to adjust it. Here in the lower part, we see the corresponding profile. And here again, we can choose, for example, on the right part to measure the distance, for example, between two peaks or between a peak and a valley, or maybe between two valleys. Okay, so now let's move on to a third example, which is a bigger part that the ones that we see before. It corresponds to a pin chip. So for this sample, we can adjust it again just by clicking and drag. And in order to obtain a stitching or extended measure, we are going to make an overview. So we move to this part of the software, and clicking on this icon, a drop-down appears in which we can choose between some pre-established dimensions, or we can enter the number of columns and rows to cover the entire region of interest. In that case, a 2 by 2 will be enough. Okay. Now it works. Okay, we are going to repeat because I think it's something related with the connection. Okay, it goes nice. So now we are going to define the number of field of views that we need to cover all the region that we want to scan. We have two options for doing that. We can click here and select the stitching area, and we can enter the number of columns and rows, or we can press this corner here, and drag and adjust to the region. So we can click Auto Light again, and then just by clicking Acquire, the topography will be generated. The resulting topography in that case will be formed by this four field of view, that we have defined before. And in this case, the total area will be 62 by 52 millimeters. So here we have the sensor view, which is the software analysis, will be open automatically. And now by applying, we move to the true color. And by applying a first holding, we can remove the substrate. If we move again to the different options for obtaining a profile, now we are going to select the free profile. In the lower part, we see the corresponding representation of the profile. And by choosing the distance, we can measure, for example, the distance between the top part of the two pins, or between the top part of the pin and the bottom part, or even the distance between these two parts. So now we are starting with the last example. It is a CSNA. And this sample is quite shiny. So let's see how it works with the system. Here, we turn to a single area instead of a stitching because we only need one field of view. Auto light and click acquire. Here we have again the 3D view of the CSNA. And now we are going to choose again the 3 profile like this. So with these, for examples, we have chosen because we think that they are representative samples of the capabilities of this system. So does it fit with your application? We hope so. And now I give the floor to Alberto.
All right, Sandra. Thank you very much for the demo. Also, thank you to Daniel. Sorry. I was interrupting you. My microphone was still working, but the speaker wasn't. So, all right. So we have now it's time for questions. You can type them as you have been doing during the whole webinar. Have been replying some of them. Also, if you want to raise your hand, I can switch on the microphone for you. Well, Larissa is asking, can you scan the other side and merge the image of the shell? Well, that is possible. Okay, so we need to take both of them. But in this case, for doing the merge, the system is automatically linked to the GeoMagick Control X or GeoMagick wrap. And if both topographies, 3 or 4 topographies, they have an overlapping, then we can stitch them together. And okay, question, what is the main difference with a digital microscope? Well, that's a nice question. Okay. Well, this is not only an inspection tool as a digital microscope, which is taking beautiful images with extremely nice, color information. This is also measured. Let's say we measure in height. So as you can see, the specs for this system and uncertainty and repeatability values measuring step height or roughness values are quite nice. This is something that you cannot get with a digital microscope. And the difference with other fringe projection system is that we also include the color information. So we have a bit of everything. Okay, you can have super nice and beautiful images like a digital microscope, and you can take 2D images, but also you can do metrology. You can do metrology in 3D. Can you level a sample based on a reference plane? William? Well, with the sensor view, yes. So as soon as the system is designed already. The stage is always flat. We level that during the production, and then once you get the topography, you can level the surface. We have different strategies. We can use the main plane. We can use rotation translation. We can use 3 points. We can exclude some area. So there are different options in the software. How well does the system work with curved surfaces and how fast? Well, as you can see, the field of view of the system is 34 by 29 millimeters. If we use the 5 megapixels camera, the acquisition time of one field of view is 11 seconds. If you work with half resolution, is with binning, then the acquisition time just reduced to 3 seconds. How is working with curved surfaces? Well, this system, as in the other question I tried to reply before, is using fringe projection. So it struggles with mirror-like surfaces. So if we have a perfect mirror optics, the system is not going to work. So we will have non-measure points. But if you have a curved surfaces with some scattering, with some texture, we can measure really step almost to 90 degrees in some cases. Okay, no question. Okay, can we, so people is asking about what is the roughness limit of the Swide. Well, if you have a micro roughness of 3 nanometers, as you have, this is not the system. Okay, for that we have you need to use a standard interferometer like the SNEOX, okay, which is also one of our systems that we offer. The system, the minimum step height we can measure with this system is around 3 microns. Okay, in some cases 2 microns, but we feel safe saying 3 microns. And the minimum roughness, I think Daniel was presenting in some slide that was presenting some roughness topographies, okay, a series of 6 topographies, and the Sensofar was evaluating and tracking how the roughness was evolving. In that case, the roughness was from 5 microns to 11 micron array or SA. So is it the system to measure roughness? Is it suitable? Well, in some cases, yes. So for example, if you have all the additive manufacturing parts, which are pretty rough, in some cases you have 40 microns, yes, the system is working. Okay, or these laser texturing surfaces we were showing, yes, it's possible. But not for if you want to measure a mirror or a lens, then we need to go for a standard optical profilometer as this news. Okay, another question from Francisco. Which is the smallest height measurement that can be taken? In some cases, we can get up to 1 micron. It really depends on the texture of the surface, but 3 microns will be safe. Is there a separate option for 300 by 300 millimeter stage? Yes. All right. So we have the standard system, tabletop system is coming with a bridge, and we got 100 by 150, and then we have the other one. So today are already available at both versions. Okay, so in this case, the bridge is wider, and then we need to assemble the system in a breadboard. Okay, it doesn't have to be an isolation table, since the system is not so critical as an interferometer, but it's still we need a breadboard. Anyway, we will send to you all the product guide of this system with all the options available. Can you easily convert these scans to be able to print on a 3D printer? Narisa was asking that. Yes, so our format, the PLUX, we can export, but this is a standard format where we can export that to many other formats. Okay, so we can export in cloud of points, in STL. So yeah, so we are even X3P. Okay. Which is the cost of the Swide system? Okay, and a very, very basic configuration will be between 75 and 80,000 euros. I think with 85,000 US dollars, we have a nice and complete system, including stitching. Okay, and the 300 by 300 is close to 100. But this system has different options. So as soon as if you send samples to us, we can evaluate. We will be more accurate, telling you exactly which is the price. The system, the standard version is coming. It's a stitching option. Is part of the main software, or we need to buy it separately? It's optional. Okay, the software is coming with a SensoScan and SensoView for the basic analysis. If you want to do a stitching, it's an external module. If you want to do automatic, so you want to do recipes and to program the system to go directly to different locations and to automatize all this process, then this is an external module. But the stitching, I think, will be very common for this system. Which is the lead time for the delivery? Well, we just launched this product now. It's really brand new product for us. We are delivering. We will deliver the first unit in June. Actually, on that point, can you convert Neox scans to print 3D printer? Okay. Oh, we can talk later about that. Yeah. Okay, that was a lot of questions. Happy to see that. There's one raised hand. Let me look for that. Let me open the microphone for you. Hello? Apparently the speaker is not working. Okay, another question. What are the standard step heights provided with the system? Well, we are working with different national institutions to provide something certified by the national institution. For the moment, we produce them. Okay, it has been it's in a step height, different step height manufactured and designed by Sensofar, and for the moment we are offering also the certification of them. Is the company doing okay with the COVID-19? Yes, happily and luckily, all the people at Sensofar are good and healthy. Fortunately, we had the government in Spain, they closed all factories or non-essential factories during 15 days. But since April 14th, we are coming back to work. Well, I have been working from home, but let's see, the factory will be opening. So at the end, together with the Easter holidays, we only closed the factory 5 days. But yes, the numbers in Spain are pretty impressive. So Chain Taya, see? Do you want to share something with us? I open the microphone for you. You will have the hand raised.
Hello,
Hello.
Alberto, can you hear me?
Yeah, I can hear you very well.
Hello. Yeah, hi.
Yeah.
I just needed to ask one thing. Like the optical profilometer, we can have option of
I lost the sign now. I'm sorry. I cannot hear you anymore.
Hello.
Can you type it, please? Or hello?
Can you hear me?
Now, yes. No, I can.
Yeah. Do we need to buy the active vibration isolation table with this system? Like
No.
No.
No, it's not necessary. No, it's not necessary at all. Okay, yes, a standard bench table from the lab is working perfectly. We don't need that. This is not an interferometer.
Okay, yeah, thanks.
Okay. Okay. So can you provide information of the other system provided so far that can measure submicron? Well, yes. So in fact, during this April, we have organized three other webinars. The next one is about dental implants, so characterization of dental implants. This is more in the medical device industry. Then we have another one about tooling and cutting edge, how we characterize cutting edge in tooling market. And the last one at the end of April, we make a summary, it's a master class of different optical metrology techniques, where we explain confocal interferometry and active illumination focus variation. So I invite you to assist to the last one. Here we'll go deeper in the technology. But if you want really more information about the SNEOX, of course, we can contact later and we can explain you anything you